Math-sayang araw mga batang mandunong. Ako po si Erica Angelica S. Benson, isang guro mula sa City of Mandaluyong Science High School at narito po akong muli upang ipakilala ang ating speaker para sa Week 9 ng Project SOAR, series of online academic reviews of mathematics CLAID module. Our speaker for pre-calculus for Week 9 is a graduate of Rizal Technological University with a degree of Bachelor of Secondary Education, major in Mathematics. She is previously an MTech coach in Immaculate Conception Academy, and she also served as a curriculum developer in Mathematics, a Singaporean math tutorial center. She is also a Gawad Kalinga volunteer and a trainer of White Team Leadership Training Team up to present. Let us all welcome Mrs. Nadia L. Olios.
Thank you, Mrs. Benson, for your introduction. A blessed day, everyone, especially to our dearest mathematics supervisor, Sir Resty Rodelas, to our principal, Sir Eric Menjola, to our head teacher, Sir Ting Nervar, to our focal person, Ma'am Stephanie Tubabair, my students from City of Mandaluyong Science High School, 11 Schrodinger, Irma, Polly, and Beilstein, and of course to my family and friends. Again, good afternoon. I am Mrs. Nadia Olios, and I will be your teacher for Week 9 of Pre-Calculus. Let's begin. In this session, we are going to talk about solving trigonometric equations and problems involving trigonometric equations and identities. Let's start. So the first problem is asking for us to find all the angles between 0 and 2 pi which satisfy the equation. Meaning to say, we are going to look for all possible values of x from 0 until 2 pi. Remember, when we are solving for equations, it must be equated to 0. But before we do that, we will manipulate tan squared x, okay, from what we learned in trigonometric identities. So we are going to express tan squared x as secant squared x minus 1 so that we can combine like terms. So we're going to expand the left side and combine the like terms with the right side. So we will have 6 secant squared x minus 7 secant x minus 20 equals 0. Then we are going to express the given in factored form. So the factors are 2 secant x minus 5 multiplied by 3 secant x plus 4 equals 0. Then we're going to equate each factor to 0. Hence, we will have secant x equals 5 halves, or secant x equals negative 4 thirds. Since secant x, or secant, is the reciprocal of cosine, therefore we will have cosine equals cosine x equals 2/5 or cosine x equals negative 3/4. Recall that if x is greater than 0, then it falls under the first and the fourth quadrant. And if x is less than 0, then it falls under the second and the third quadrants. So for x is equal to 2/5, the value of alpha is equal to 1.159. If cosine x is equal to negative 3/4, then theta is equal to 0.7227. So since we're looking for all possible values of x from 0 to 2 pi, we have 2 pi minus 1.159, which is 5.12, And for negative value, we have pi minus 0.7227 and pi plus 0.7227, which is equal to 2.42 and 3.86. Therefore, all possible values of x are 1.16, 2.42, 3.86, and 5.12. Next given. Solve for the equation using trigonometric identities. We have 2 cosine theta plus 2 sine theta equals 1 all over 2 cosine theta minus 2 sine theta. For theta is greater than or equal to 0 degree but less than or equal to 360 degree. So later on, we are going to use that condition to find all possible values of theta. So multiplying both sides by the denominator, 2 cosine theta minus 2 sine theta, we will have 4 cosine theta squared minus 4 sine squared theta equals 1. Then again, we are going to express either cosine squared theta or sine squared theta as another trigonometric ratio so that you can combine like terms. I will express sine squared theta as 1 minus cosine squared theta. So after this, we will expand. We will have 4 cosine squared theta minus 4 plus 4 cosine squared theta equals 1. Then combining like terms, we will have 8 cosine squared theta equals 5. So dividing both sides by 8, we will have cosine squared theta equals 5 over 8. So to fully isolate cosine theta, we will get the square root of both sides. We will have cosine theta equals positive or negative square root of 5 over 8. So remember that if cosine theta is greater than 0, then it's on the first and the fourth quadrant. If cosine theta is less than 0, then it's on the second and third quadrants. So therefore, if theta is 37.6, to get all possible values of x, we have 180 minus 37.6, 180 plus 37.6, and 360 minus 37.6. So therefore, all possible values for the theta are 37.6 degrees, 142.2 degrees, 217.8 degrees, and 322.2 degrees. Next, let's talk about our formulae. So in summary, our formulae is this. So a sine theta plus or minus b cosine theta is equal to r sine theta plus or minus a. And a cosine theta plus or minus b sine theta is equal to r cosine times the quantity of theta plus or minus alpha, where r is equal to the square root of a squared plus b squared, and tan alpha is equal to b over a, where alpha is a cube. Okay, so let us try to solve the following. Express for sine theta plus 3 cosine theta in the form r sine quantity theta plus alpha. where r and alpha are constants such as alpha is acute. Hence, solve the equation 4 sine theta plus 3 cosine theta equals 4.8 for values of theta between 0 degree and 360 degrees. So in this problem, we have two tasks. The first one is to express the given in R form or in R formula. The second one is to look or to solve for the equation for values of theta between 0 degree and 360 degrees. The first thing that we'll do is to let 4 sine theta plus 3 cosine theta be equal to r sine theta cos alpha plus r cos theta sine alpha. If you remember, this is from addition formula, where theta and alpha are a and b. And then, we will equate the coefficients of sine theta and cosine theta. So 4 equals r cos alpha for the first equation, and 3 equals r sine alpha for the second equation. And then we will divide the second equation by the first equation to get tangent alpha, which is equal to 3 over 4. So theta or alpha is equal to 36.87. And then squaring and adding equations 1 and 2 will give us 4 squared plus 3 squared equals r squared. Therefore, r is equal to 5. So now we can express 4 sine theta plus 3 cosine theta, which is equal to 4 sine theta plus 3 cosine theta equals 5 sine quantity theta plus 36.87 degrees. So after this, we're going to solve for the equation sine theta for sine theta plus 3 cosine theta, which is equal to 4.8. So since 4 sine theta plus 3 cosine theta is equal to 5 sine quantity theta plus 36.87, we can have this equation. So it's equal to 4.8. So dividing both sides by 5, we will have sine quantity theta plus 36.87 degrees equals 0.96. Then we will have theta plus 36.87 degrees is equal to 73.74 degrees. So since the condition says that alpha is acute, okay, and it is stated that the values of theta is between 0 degree and 360 degrees, we will consider 180 degree minus 73.4 degrees. So the possible values for theta plus 36.87 are 73.74 degrees and 106.26 degrees. And so theta are 36.9 degree and 69.4 degree. Now let's talk about maximum and minimum values. So given the expression a sine theta plus b cosine theta, how do we determine its maximum value and the corresponding value of theta? Recalling from chapter 8, we have sine quantity theta plus alpha is greater than or equal to -1, but less than or equal to 1. So since we have square root of a squared plus b squared, which is greater than 0, we'll have this one. Therefore, the maximum value of a sine theta plus b cosine theta is the square root of a squared plus b squared. And it occurs when sine quantity theta plus alpha is 1. Similarly, the minimum value of a sine theta plus b cosine theta is negative square root of a squared plus b squared. And it occurs when sine theta plus alpha is equal to negative 1. So let us try to find the maximum or minimum value of the given. Express 8 sine theta minus 5 cosine theta in the form r sine quantity theta plus alpha, where r and alpha are constants, such as alpha is acute. Hence, find the maximum and minimum values of the expression such that theta is greater than or equal to 0 degree but less than or equal to 360 degrees, and the values of theta for which these values occur. So equating coefficients of sine theta and cosine theta, we have equation 1 and equation 2. Dividing equation 2 by equation 1, we have tan alpha equals 5 over 8. And alpha is equal to 32.01 degrees. To the square root of 89. Hence, 8 sine theta minus 5 cosine theta is equal to the square root of 89 sine quantity theta minus 32.01 degrees. So the maximum value of the given is the square root of 89 when sine quantity theta minus 32.01 degree theta equals 1. When theta is 122.0 degree. So again, the maximum value of the expression is square root of 89 when theta is 122.0 degrees or 122 degrees. And the minimum value of the given is negative square root of 89 when theta is 302.0 degree. Let's talk about this problem. The figure shows the sketch of the cross-section of a tunnel in the shape of a semicircle, center O, and ABCD is a rectangle. The radius of the tunnel is 18 meters. Angle AOB is equal to angle COG, which is theta, and the perimeter of the rectangle ABCD is P meters. Show that P is equal to 36 sine theta plus 72 cosine theta. Express P in the form R sine quantity theta plus alpha, where R is positive and alpha is acute. And state the maximum value of P and the corresponding value of theta. So let's start. First, we will show that P or perimeter is equal to 36 sine theta plus 72 cosine theta. So we are going to express that the perimeter of rectangle ABCD is 36 sine theta plus 72 cosine theta. In triangle AOB, sine theta is equal to AB over 18. Hence, AB is equal to 18 sine theta. cosine theta is equal to OA over 18. Hence, since side AB is equal to side CD, and side AD is equal, therefore we can say that P is equal to 36 sine theta plus 72 cosine theta. And hence, 36 sine theta plus 72 cosine theta is equal to 36 square root of 5 sine times theta plus 63.43 degrees. So express P in the form R sine quantity A quantity theta plus alpha, where R is positive and alpha is acute. So R is equal to the square root of 36 squared plus 72 squared, which is 36 square root of 5. So tan alpha is equal to 72 over 36, which is 2. And alpha is equal to 63.43 degrees. For the last problem, we have state the maximum value of P and the corresponding value of theta. So the maximum value of 36 sine theta plus 72 cosine theta is equal to 36 square root of 5 when theta is 26.6 degrees. So I hope you learned a lot from the last session of Pre-Calculus for Quarter 2. Thank you for listening. Again, this is Mrs. Nadia Olios from City of Mandaluyong Science High School. Goodbye, everyone.